It's because I gave you the whole access.
Oh, I see.
Yeah.
I gave you co-host already. There we go. Okay, I think we're good to go.
Okay. So, thank you for coming. Thank you for coming to our workshop session 4. Again, my name is Jing Jing, and Cynthia Harry and this session together. Today we will finish data wrangling, and tomorrow, Wednesday, we will have an extra session at the same time from 2 to 4 o'clock. And also, if you attend in person, it will still be in this lab, the lab 16, and we will talk about data visualization tomorrow. So for data wrangling, we focus on 2 packages, dplyr and tidyr. So last week we covered a couple functions in dplyr, select and filter. We use these 2 functions to subset data frame. We use select to subset columns, and we use filters. We use the function filter to subset rows or observations on conditions. And also we talk about pipe operator. So it looks like this. And we can use the pipe operator to send a data frame to a function. And also we can use it to send the result of a function to another function. It is very helpful if we will do multiple tasks on the same data frame. It makes your code easy to write and also easy to read. And so this week, today we are going to talk about another function, other functions, I mean. The first one we're going to talk about is mutate. So sometimes we want to create new columns, new variables based on the existing function, based on the existing variables. So the function we're going to use is mutate. And before we start today's coding, we can go to, okay, first you need to download the Starfy zip file and to your own computer and unzip it. You will see a Starfy folder. You open the Starfy folder, you will see this Starfy R project. Double click this Starfy R project to start a new R session. If you are using the lab computer, you need to install tidyverse. So you can click the package tab and click install and key in tidyverse here, and then make sure the install dependencies is checked. Then click install. It will start the install process. After installation, or if you're using your own device, just go to the files and in the scripts folder, double click this R script, S3 data wrangling. So we open this file. It opens in the script editor, and you can scroll up to the very top and select these two lines, the line 5 and 6. Run these two lines. You can use Control Enter. The first command is load tidyverse to your current environment. The second line will read the CSV file, the data set into your current environment, and you can see it here on the environment tab. It is assigned to the object interviews, the data frame interviews.
Maybe we should ask now, Justine, does anybody have a question? If you have a question, if you're on the Zoom, feel free to unmute and ask, or drop it in the chat, or if we have a question here in class. Yes.
It does not show.
Not sure what. Did you run both of these?
You have this.
Okay. And how are you doing?
Library tidyverse.
Yeah, did you get tidyverse to load?
It's no package called tidyverse. You need to install tidyverse and click install.
Okay. I'm not sure it ever did. Now run this line.
Yeah, it says the error message says you don't have the package. So it may take a couple minutes to install.
Because it says it's no, I mean, she clicked enter and it ran it, and then it said it's here. Oh, it says not available for this version of R. This package tidyverse is not available for this version of R.
There's an E. BRSE.
She just typed in TIDD, I'm sure. But here, just click right here so you know that's spelled. All right, there it goes.
You want me to take it?
Sure.
I think I can twist it around.
Okay. Oh, you think you could twist it around? I'm sorry. I was already here before I even understood what you were. Okay, I think you're good to go. You look like you're running good. Did you run these lines up here?
I think so.
So any questions from Zoom or from online? If you already have your tidyverse loaded to the environment, and also you have the object interviews created. Could you kind of type in something in the chat? Let me know.
I think you're right.
Yes.
Okay, I think we're all okay on line 2.
Okay, so now we are on the same page. We can go ahead and talk about the function mutate. So let's say we have the in our data we have the number of household members, and also we have number of rooms each family, each house has, and we can calculate how many people per room. So we can use the function mutate to create a new column. Okay, let's do it. We start. Oh, sorry. Back to. Here, let's say we create a new session. Yes, I pressed the wrong button. So we can create a new session, use Control Shift R. We just say add new columns. And then the function we're going to use is mutate. And we start with interviews, and then we use the pipe operator. The shortcut is Control-Shift-M, and then we hit enter. We're going to use the mutate function, and we will create a new column. It's called people per room, and it equals to number of household members divided by rooms. When we use Control Enter to run this command line, we will get a new table. It is 131 rows and 15 columns. Instead of 14 columns, we have 15 columns. And then we can see the last column, it is people per room. To see it, we can send it to, we use the control, the pipe operator, and send it to the function view. When we run it, it opens in a new tab. And we can scroll to the most right and see this value, see this new column. The function mutate, it basically has two parameters. The first parameter is the data frame, and the second parameter of the parameters follows will be the new column. So we can use this pipe. We can also just write it. We will get the same breakdown. Pipe will send the data frame to the first parameter of your function. So this time we can write command, let's say, kind of combine filter, mutate, and select. So we know we have a column is called member of associations to see if a member is part of an irrigation association. You can double click and see this. Double click this data frame, and then you can see it open on a new tab. And we have the column is called member of association. We have missing data. We have yes, this family is the member of an irrigation association, and this family is not. So this time we want to use those observations who answers either yes or no. we will kind of ignore or remove remove all those missing data. Okay, so first we still start from interviews, and then we want to filter out. We want to keep only those who answers the question. So member association. This will keep all the records, the missing record. I mean, all the records the respondent did not answer this question. If we want to make them opposite, we use this exclamation. So we can send this. If you're not sure about the results, you can always send the results to the view function. And when you control enter, you will see the results. And this one, we have only 92 observations instead of 131. So you can go to the member association, you can see all those NA are gone. And we keep all the observations, all the respondents who answered this question. And next, let's say we still want to calculate. People per room. We just copy and paste it here. And we don't want to display all those 15 columns. We want to select some columns to display. Let's say we want village, number of household members, and we want to show rooms, and also we want to show people per room. Since it is kind of smaller.
Sorry, I have a question. I think my view function is not working. I didn't know like why it's not coming, the view.
Okay, when you have the view, did you have this pipe?
Pipe, yeah, I have the pipe.
Okay, so when you have that, when you run that, it will open a new tab. You see the dot on the top, which means current, and you will see it here.
Okay, let me try again. Okay.
We run it, it opens. Okay, I can close it, and then when we run this command line, and it opens a new tab. The name of this tab is kind of dot, and then you see the frame, the data frame. Does that work?
No, I think there. I'm sorry. I will figure it out. I think I misquote something or misspell something or something. Comma. I'm looking on it. Carry on. Thank you.
Okay.
But Gigi, maybe turn that speaker down a little. It's at the so that you know. I think here. Here. Not make you too low too.
So we good with this function, this kind of long command line. We have a combination of filter, mutate, and select. And when we run that, we will see the result. here. It is a 92 by 4 data frame. You see village, number of household members, the number of rooms, and the people per room. And as a result, it displays the first 10 observations, the first 10 rows. Any questions? I did not see any questions, and we will go to the next command. Kind of a group of commands. When we analyzing data, very often we split the rows or we split observations into groups, and then we apply some analysis, and then we want to display. We combine the results and display it. So we call this kind of split, apply, combine model. The functions we're going to use is group by and also summarize. So we kind of use these two commands together. So let's take a look at an example. Let's say we want to calculate the number of household members, but we want to the average of the household members, and we want to calculate them by village. So can break it. Okay, so Control Shift R, and then let's say split Y. And we will still start from interviews. We can use group by. We want to group by village. And then we send the results to summarize. You can use SE or you can use ZE, both words. And we want to calculate mean number household members, and that will be mean when we run code, we see the average household members by village. The Sage village is kind of a little bit over 7. The God village is 6 something, and the R village is 7.55. I remember last time or a couple weeks ago, we had a question. Let's say if we want to calculate how many respondents in each village, we can do this calculation too. Let's say interview, and then field group by village. And then to calculate number of observations, we can use N, the command N. we can also group by several variables or several columns. And also we can do multiple calculation. We can calculate kind of multiple values. Let's say we can group by village, and also we group by member of associations, see if they are members. And we can calculate meanwhile we calculate the minimum. So we group them by two variables, village and if they are member of association. And we calculate the average and also we calculate the minimum. When we run that, we get two kind of the calculated values. One is the mean and another is minimum. And also for the categorize, we have village, and then we have member of association. They know, yes, and missing data did not responded. Another village, the same, and our village. We can use summarize kind of. We don't have to associate with summarize functions. Let's say we can comment out this group by. It will calculate how many records we have in this data set. The result will be 131. With this group by, it will calculate 3 different results. One from each kind of the respondents from each village. And also group by can use with other functions than summarize. Let's say we can use it with mutate. We still group by village, and then we can add mutate and number of hills, and then we can calculate number of hills. And then when we see the result, the new result, the results will 131 by 15 columns. So we have a new column. It's called the new column should call mean number of mills. view. And then when we write, we will see this. The kind of average number of fields by village. So these two must from two different villages. And this is another village. So we have 2.55, 2.61, and 2.63. And also when we use group by, a good practice is to use, after we use group by, we use ungroup to ungroup the data set. Okay, I will show you what I mean. Turn use and we set it. Here we group by visit. And then we will add a new. Let's calculate this. But between those two mutate, I add another function ungroup. And then we set it to view. So we group by village and we calculate, we add a new column. It's called mean number of meals, and we ungroup the data sets. Then we add another column. It's called mean number of household members, and then we see the result. So when we scroll to the right and we see number of meals, we still remember those two numbers, 2.55, 2.61, but in the mean of the household members, we have only one value. That's the average household members across all the data frame, all the data set. It's not grouped by villages. Does that make sense? So sometimes when you have your data sets and you want to do some calculation, if you don't want the data grouped by certain column or certain variable, you have to ungroup it before you start the next calculation. Any questions so far? Group and summarize is kind of commonly used combination for group by, summarize, group by, mutate. Is a commonly used combination. So if you have any questions. Okay, so we will talk about next function, arrange. we will sort results. So we will still start from interviews, and then we send it to copy the one we did multiple calculation. We did the moved by 2 variables, and we sent the results to arrange. We arranged by minimum numbers. So when we arranged by minimum numbers, the minimum numbers will sorted ascending. If we want it to be descending, we just add another function, descending. Now it's descending. So next we're going to talk about the function counts. Kind of the self-explanatory. So you can do the calculation. I mean, counts the records, how many rows. If we want to sort it, we can add another argument in sort. And we set it by default, it was false, and then we assign it as true when we run it. It will sort descending. Any questions so far? If we want to sort ascending, and just send it to so we can quickly summarize what about dplyr, the functions in dplyr. Last time we talked about this too, and this time we use mutate to create new columns based on existing columns. And we use group by and summarize to create kind of create a summary statistics based on the group data. And also we can use ungroup to kind of ungroup the data but back to the original status. And we use arrange to sort results, and we use count to calculate how many observations in the data.
In chat, they were asking about the pipe operator. That command is Control Shift M.
And yeah, Control Shift M. There are more functions in dplyr, and we just covered this 7 or 6 functions here. So next we're going to talk about tidyr. So, okay, so from its name, we can tell this package will help us tidy the data. But what is a tidy data? So the concept comes from person is one of the earliest developers of tidyverse. And also he is also the person of the book R for Data Science. I think we have that here. Yeah, this is the book. It is widely used when people start to learn R. This is a pretty good book. And he kind of give us the 3 principles to follow when we talk about tidy data. The first principle is each variable must have its own column. And each observation must have its own row. And each value must have its own cell. So we will see an example of tidy data. So the library tidyr includes some sample data. So this is the one, it's called table 1. And we will use this, the sample data comes with the tidyr to explain what is the tidy data and what messy data. So tidy that data, here we see those records. See each variable has its own column. We have 4 different variables: country, year, cases, and population. They have their own columns. And each observation have its own rows. And each data, each value have its own cell. And next we will see some. So this is called table 2. And we can see here the variable cases and population. They are kind of split into 2 rows. For the data, Afghanistan, and in the 1999, the data, the case, and the population are split into 2 rows. There's 1 observation in 2 rows. And for this one in the middle, that's table 3. And the cases and population is put into 1 cell. They name it but we can actually split them into two columns. And if you want to calculate rate, we can create another column. Next example of messy data is table 4. They kind of have two tables. One is table 4A, that's for cases. And another one is table 4B for population. In this example, the cases, the variable cases is split into two columns. One for the year 1999 and another column is for the year 2000. When one observation is split into two rows, or one variable is split into two columns, we can use the function pivot. We can use pivot functions to hiding the data. So it's basically we use the pivot table, the pivot function, pivot wider and pivot longer to convert between the long format and the wide format. So we will start with this table 4 here. This is the data. Table 4 for the cases. And we want to convert it to the format of this. The 1999 and 2000s, they are not really variables. They are just the values of the variable year. So we want this column name go to this new variable year. And we want this data go to cases, the value. The function we're going to use is pivot longer. This kind of a wider format, we convert it to a longer format. So the function pivot longer, it has 4 arguments. The first argument is the data frame. Data frame we want to convert. The second argument is the columns. Columns to be reshaped. Those 2 columns, we want to reshape it. And the names too. So this 2 columns is basically 2 parts. One is the column name, another is kind of the values in those columns. The columns name, we want to put them into a new variable, is called year. So the third argument is names too. All the names will go to year. And the values, that's the values too, that's the 4th argument. That will goes to cases, a new variable. So first we can take a look at table 1. That's the tidy data. And the data we want to convert is table 4A. So this is how it looks like. Table 4A, we want to send it to the function pivot longer. The first argument is table 4A, so it's the data frame. And the second argument will be the columns. The two columns, 1999 and 2000, we want to convert. So the column the third argument is names too. We want those two, the column names goes to year. And the next argument is values too. That will be cases. So when we run this code, we see the result. So now the years goes to the variable years, and all the values goes under cases. To make it easy to read, you can always enter at each argument. So there, still the same. R is kind of different from Python. Python, when you have some space in front that have meaning, but in R, it doesn't mean anything. You can just remove those spaces, but we have these spaces just for the readability, to make it easy to read, kind of understand. We can do the same thing for the table 4B. So that's the one for population. It's in the same format as we saw in the cases in table 4A. So you can just copy the code and change A to B and change cases to population. Should be good. If we want to kind of merge this table, these two data frame into one, just like table 1, we can use the function join. Okay, so first we can assign the results back to table 1A, and also we can assign this to table 4B. And we rerun those two commands. We kind of updated table 4A and table 4B. We want to join them. We can use the function left join, and then now we see the results. It's kind of same looking as table 1. We have country, year, cases, and population each have their own column. Each observation has their own row. Any questions? If not, we can take a 4 minutes break. We come back at 3 o'clock. Before the break, we talked about the pivot when the data is when the data one observation is split into multiple if one variable is split into multiple columns, we can use pivot longer to tidy the data. Convert it to the longer format. And pivot longer has 4 arguments. The first one is data frame. The second one is columns we want to convert. The third one is names two will convert convert the variable names to a new column to make it the value of a new variable. And the last one is values too. It will convert all those values in the columns into a new column, a new variable. So next we are going to talk about pivot wider. Opposite to pivot longer, when we have one observation scattered across multiple rows, like this one, we have like this one, we have cases and populations split into 2 rows. They are just one observation. Then we can use the pivot wider to convert them to the tidy format. Pivot wider has 3 arguments, the basic 3 arguments. The first one is the data frame, and the second one is names from. That's the where the new column names is from, and values from. That's the value of the new columns. Take a look at our data. Our table 2 is in this kind of situation. We have cases and populations split into 2 rows. So table 2, we start with table 2 and we send it to pivot wider. And the first argument is the data frame. The second argument is names from. One is values from. We see the tiny format. So we can use the pivot functions, pivot wider and pivot longer, to tidy the messy data if one observation is scattered across multiple rows, or if a variable is scattered across multiple columns. We can also use these functions to help analysis. For our own data interviews, can first. We have column is called items owned. So it records kind of what items each family owns. If we want to calculate, say, how many items each family owns, in the current format, it will be difficult to calculate. And we can use the pivot function to make the calculation easier. Okay, so the function we're going to use is pivot wider. Okay, this is currently how it looks like. And if we can use pivot wider to convert into, let's say we use the items as the column name, and then we have true if this respondents have this item, and we will have false if they don't. And based on this new format, we can easily calculate how many items this family has. So we can use the function, let's say interviews and pivot wider. We need names from, and also we need values from. Those are the two basic arguments, or three basic arguments. Pivot wider text. And for names from, that must be our items owned. But it seems like it's not the format we saw before. This is the format we saw before. We have cases, we have population, and then it's converted to the variable names. But here, we have them kind of together, split by this semicolon. That's not the format we want. And another problem is we don't have a value. We don't have the true or false value here. We don't have a column for values from. So before we can use pivot wider to do this conversion, we need to kind of transform the data or the format into the one kind of we can use, fit we need to kind of create those two columns before we can use pivot wider. So let's do that. Back to say apply pivot wider to clean or to tidy our data. So we still start from interviews, and we send it to a function we call that separate rows. And the rows we want to separate is items owned. And the separator is semicolon. So to see that, we will send it to the view function. See how it looks like. So instead of having all those items in one cell, now separate into different rows. So for the first record, I think it's split into 4 rows. The first family has 4 items. And the second family, it has more. So it's split split into even more rows. It looks more like this type. And now it's kind of items own, and it's bicycle and always split. And also we can see the rows. Instead of 131 rows, now it has 631 rows. Because each of the ration is split into multiple rows. So we kind of solved the first problem. We solved the first problem. We kind of create the items row. Those items in separate in different rows. And we are looking for a solution for values from. We can, let's say, for this one, we can add a new column here. To add a new column, the function we're going to use is mutate. We will add a new column. It is called item owned logic. And we assign it to true. Now we take a look at the result. So now we have this item owned, and we have this true column. If this family owns bicycle, the value is true. If the family owns a television, the value is true. If they don't have the item, if they don't own the item, that will be the missing data. So after we kind of create or make the transform the format, and we can try to use pivot wider. And we will have the names from, it is from items owned. And we will have values from. It's the items. Okay, I guess I select. I forgot to send it to you at this type, and then we send it to you. So here we see we're back to 131 rows, but the columns changed. Instead of 14 columns, we now have 31 columns. So we use 4 right, and you will see the new items, new columns added. Bicycle, television, they all become column. And also the first family, we know they have 4 items. All those 4 items display as true, and all the other columns, they display NA, missing data. With me? If you have any questions, okay, when we score right, we may notice there is a column called NA. We don't want it displayed as NA. We want to change the name before the we pivot it wider. So we can make some changes to the command. Okay. We can add something. We can change the NA into something else. We can use another function, it's called replace NA. We will use the function list, and it requires it to be a list. And items on to listed. Then we will send the readout to the next step. So this command line will replace NA with no listed item. When we run this, and instead of NA, it's now replaced with no listed item. Here, we want to convert this to this format. And if they have the item, we say true. Otherwise, we say false. But now we have true, and we have missing data in A. We want to fix that. We can make some kind of further modification. Here, we kind of create the logical column true. And then we send it to the pivot wider. Pivot wider has those 2 arguments. It has more arguments than those, and it has another argument. It's called values field. It equals to, here we need to use list. We assign items on logical to false. When we run the command again, and for right, we see true and false if they don't own the item. We want to calculate how many items each family owns. We need to add another column. Use the function both select. So first we select path. That's the current data frame, and we want bicycle. Here, we want it from bicycle to the last one, car. So we want to calculate this column, select all those columns, and we calculate row sum. If the value is true, it will be considered as 1. If it's false, that will be 0. So this result, we will get how many items each family has. And we send it to you. Then we take a look at the result. At the very end, we have the number of items. Any questions or any problems from this calculation? The first family, we know they have 4 items. The result is 4. The second family, we know they have more items. And now we know they have 8. It sounds like correct. But for families, they don't have any items. No listed items. And this row is true. When we do the calculation, the number of items is 1 instead of 0. So we want to fix that. So we can take a look. So the column to its left, right, and it's a discount. And the column to its right is fridge. So to do the calculation, we can do motor.
Yeah, that's right. Okay, got it.
And fridge. We can kind of skip the items, no items owned. And then we redo the calculation. And this column is, this family doesn't have any item. So we fix that. Any questions so far? in our data set, we have another column. It has the similar problem. That's the month's lack of food. You can follow the steps we just went through to add a new column to kind of calculate how many months each family a lack of food. You can write the code yourself. For replace NA, here in this column, there's no NA. If this family doesn't have any kind of, they are not lack of food in any months, it will be none. So we don't need this replace NA function. We can go directly to kind of add a new column, the logical column. Before I can do the calculation, I need to know the column. So I just set it to, and I can take a look at the value. So see, the first column added is January, and the last column is none. And the one before last is May. And I don't want to calculate this column. It is at the end, so I just need to calculate for January. That's easier to do than the items only. the result. You can see those families, they don't lack of any food in any months, and their result is displayed at 0. So that should be correct. Tomorrow we are going to use this data to do the visualization. So we want to combine these two commands into one. So we will start from and everything before view. And then you copy everything from here. From the if both kind of commands work. To make it easy to read, you can add some kind of
Spaces.
add spaces, or you can add here. That can help you remember what you are doing using this. If you want these two new columns to be together, you can move this command, this part to here. So that will do the calculation. Okay, we send it to you. You run that, and you will see all the new columns created. That's from items, months, and at the very end, we have two calculated. One is for the items owned, and another one. Sometimes you cannot just reorder the functions, reorder the command, but in our case, and we can assign it instead of put them into view function, we can assign them certain options. We can assign it to this new data frame. Interviews one items. One. So if you have any questions. Since we are going to use this data set to for the next session, for tomorrow's session, we want to export this data into a file that will be there to use tomorrow. So next we are going to talk about export that. The command we are going to use to export a data is write yes. Before we write export our data, we want to put it into a new folder. We call that, let's say, data output. So you can create a folder here by clicking this button. Then we can create data output. Or you can use another command line. So to use the function write CSV, we start with the data frame name, interviews plotting, and the file name. Data output and /. We will call that interviews plotting .cs. Interviews plotting. The folder, the path is under data underscore output. And the data frame, that's the one. We run this command, and when we click open this folder, we see a new file. My last slide. The takeaway from the session. From the second half, we talk about the tidy data. 3 principles. Each variable must have its own column each observation must have its own role and each value must have its own self. And we use pivot wider and pivot longer to reshape the data, tidy the data. And also we use pivot wider to process our data set, to calculate the items each family owns and calculate the months, how many months they are lack of food. And then we use the function white_cxt to export data. So talk about the tidy first, I mean the dplyr and tidyr. It has more functions than we introduced. You can go to the guide and in session 3, data wrangling with dplyr and tidyr, you can see the additional material. We have RStudio cheat sheets. When you click the cheat sheet, you can see this is the cheat sheet for dplyr, and this one is for tidyr. So you can open and you can see the functions we kind of talk about filter, and we talk about select. We talk about summarize, count. We only cover some of those, and there are more functions you can use here. Talk a little bit about join. You have 4 different joins: left, right, inner, and full. And for tidyr, the most important functions in tidyr is the pivot wider and pivot longer. Pivot wider and pivot longer. It also has some other functions. We have separate rows. There's a separate we didn't talk about. I don't know if you still remember when we see these 3 different types of messy data. The one in the middle, we have values, cases, and the population in the same cell. They are kind of split with the, you see that, the forward slash. And you can use the function separate to separate them into 2 columns. So basically, dplyr and tidyr help us to transform data into the format we want, into our own logic. We want to use them. That's all for today.
Don't forget to do your evaluation. I just dropped it in the chat. And then the evaluation's at the top of this page. Oh, it's all the way at the top. There you go.
And also on this side, we recommend other books. This one is a very good one. And I think if you are looking into something like statistics, and this is a good one. This is for biology, and this is using R to do the statistical analysis. tomorrow we're going to talk about ggplot2, using ggplot2 for data visualization. You already see that the cheat sheet is here. And anyway, if you have time, you can come back tomorrow at the same time.
And we'll have the same Zoom link, so if you're on Zoom now, you can use that same link to get back in. We're just using that extra session, unfortunately, because we had such a hard time the first session that we kind of threw our schedule off. So come on back tomorrow from 2 to 4. We'll be here. Y'all can be here too.
And I will send out the zip file from today. So if you're missing anything, yeah, that file will help us. on the same page.
Unless anybody has any questions, I'm going to go ahead and stop the recording and close the Zoom. You're welcome.
If you have any questions,